When you think about it, diesel engines are everywhere. They're the absolute workhorses of our world. We're talking about the massive trucks that haul everything across the country, the tractors in our fields, the ships on the ocean. They literally power our economy. So let's dive in and really get to the bottom of the incredible engineering that makes them tick.
But right away, we run into this central mystery. The gasoline engine in your car, it needs spark plugs. But a diesel engine, it doesn't have any. Not a single one. So how in the world does it ignite fuel and create all that incredible force? Well, that's the big question we're going to tackle right now.
And the answer, believe it or not, lies in a beautifully simple but incredibly powerful principle of physics. So let's pull back the curtain on this amazing, sparkless secret.
Okay, so here's the fundamental difference, side by side. A gasoline engine, it takes a mix of air and fuel and then needs an outside trigger, that little electric spark, to get things going. A diesel engine, on the other hand, it does something totally different. It creates its own ignition source, using nothing more than air and a whole lot of pressure. The name for this whole process is compression ignition, and it's just a brilliant concept. Instead of adding a spark into the mix, you just squeeze air so hard and so fast that it gets unbelievably hot. I mean, it gets hot enough to instantly set fuel on fire the very second it's sprayed in. No spark needed.
So just how much do they squeeze that air? Well, this number right here is the key. A diesel engine can compress air at a ratio of up to 25:1. Now, what that means is it takes a big volume of air and crushes it down into a space 1/25th of the original size. That is more than double the compression you'd find in a typical gasoline engine. It's just immense.
And all of that pressure creates an insane amount of heat. We're talking up to 700 degrees Celsius. That's almost 1,300 degrees Fahrenheit. And remember, this isn't from some outside flame or heater. This is pure physics. The air itself becomes superheated, creating the perfect conditions for combustion, totally on its own.
Okay, so this intense heat is our trigger. Now let's see exactly how that trigger fits into the engine's complete operating cycle, step by step. So, the diesel cycle has 4 strokes, just like a gasoline engine, but with some crucial differences. First up is intake, and here's the first big twist. It only pulls in pure air, no fuel yet. Second, compression. The piston flies up, squeezing that air and creating all that incredible heat we were just talking about. Then comes the main event, the power stroke. A superfine mist of fuel is injected, and it just boom! It ignites instantly in that hot air, driving the piston down with unbelievable force. And finally, the exhaust stroke pushes all the used gases out, and the whole thing starts all over again. And this quote just nails it. It really captures what's happening during that power stroke. It's not just a gentle burn, it's a powerful but very controlled explosion. And this immediate, violent expansion is what creates that massive twisting force, the torque, that diesel engines are so famous for.
Of course, containing that kind of controlled explosion, over and over and over again, thousands of times a minute, well, that requires an engine that's built like an absolute fortress. It has to be engineered to handle constant, violent pressure.
And that's exactly why everything inside a diesel engine is just heavy duty. The engine block itself is thicker. The pistons are reinforced. The crankshaft is way beefier to handle all that stress. You also find specialized parts, like turbochargers, which are basically there to cram even more air in for more power. And then you have glow plugs. Think of these as tiny little heaters that help warm up the engine on a cold day, just to make it a bit easier to get that initial ignition heat when the whole engine block is cold. Now check this out. The fuel injectors themselves are just marvels of engineering. To actually force fuel into a cylinder that's already under so much pressure, they have to spray it in at up to 29,000 psi, pounds per square inch. This incredible pressure turns the fuel into an ultra-fine mist, which is crucial for making sure it burns completely and efficiently the instant it hits that superheated air. So, okay, we've seen how it all works, but that kind of brings us to the next big question. Why? Why go to all this engineering trouble? What are the actual real-world advantages of this design? This chart really gets right to the heart of it. It's all about torque. See, a diesel engine produces its maximum pulling power at really low engine speeds. This low-end grunt is exactly what you need to get a fully loaded semi-truck moving from a dead stop. This is the power that keeps our entire global supply chain humming.
And the second huge advantage? Efficiency.
Thanks to that super high compression and the fact that diesel fuel itself is more energy dense, these engines are typically 25 to 35% more fuel efficient than a comparable gas engine. That means you get more work done and go a lot further for every single gallon of fuel.
So when you put it all together, it's just this incredible combination. You get superior torque for all the heavy lifting, you get greater fuel efficiency, which saves a ton of money, and you get exceptional durability. Remember, that super robust construction means these things are built to last, often for 1,000,000 miles or even more in big commercial trucks.
Of course, for a long time, all that power and muscle came with a pretty big trade-off: emissions. But modern diesel engines have gone through a massive technological revolution to clean up their act.
Today's clean diesel engines have this amazing multi-stage cleanup system. First, something called a diesel particulate filter, or DPF, acts like a super sophisticated trap for soot. Then, a system called SCR uses a special fluid to trigger a chemical reaction that turns harmful pollutants into harmless nitrogen and water. And finally, exhaust gas recirculation actually sends some of the exhaust back into the engine, which cools things down and stops many of those pollutants from even forming in the first place.
And the result of all this high-tech wizardry is that the modern diesel engine is just a completely different beast from its ancestors. It still delivers all that legendary power and efficiency we love, but with emissions that are dramatically cleaner than ever before. So, all of this leaves us with a final thought to chew on. When you really consider its unique combination of raw power, incredible durability, and now modern efficiency, you have to ask yourself, is the diesel engine the true, unsung hero that's powering our entire global economy? It's definitely something to think about the next time you see a truck, a train, or a ship hard at work.